Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology, Section A. In our previous session, we have started with a new chapter from Section A, Substances in Common Use. The substances which you use in your day-to-day life. This chapter is divided in three parts. I have told you earlier. In the first part, in the previous session, we have studied about the important salts in day-to-day life. Today, we will be studying about the radioactive substances and some of the chemical substances used in daily life. In the first topic, that is important salts in day-to-day life, what we have studied, that we are going to revise first as we do every time, and then we will proceed towards our today's topic. Important salts in day-to-day life. There we have seen the different types of salts, and the three types of salts are acidic, neutral and alkaline salts. Now, how you divide the salts in three types? On which criteria? I have told about this pH scale to you last time, which ranges from 0 to 14. You can see different colors on this pH scale. Now, the salts which have pH value exactly equal to 7, such a type of salt is called as a neutral salt. And it is made by using a strong acid and a strong base. The next type of salt was acidic salt, which has pH value less than 7. Such a type of salt is made from a strong acid and a weak base. And the third salt is alkaline salt, or you can say basic salt, which is having pH value more than 7 and made from a weak acid and a strong base. I had also told you that more in details about this pH scale you are going to learn in chapter acids, bases and salts. So for this chapter you have to remember only these three types of salts. And now we will revise the four salts which we have studied in our previous session. The first salt, as I have told you, I don't have to introduce you to you. It is nothing but sodium chloride or table salt, or the salt which forms an essential part of your daily diet. Table salt has the chemical name sodium chloride, and you know that it gives a salty taste to your regular food, any food which you eat, and it is formed by the neutralization reaction between sodium hydroxide and hydrochloric acid, that is NaOH and HCl. About the properties and uses of the sodium chloride, the first property I had told you, it is a colorless and crystalline ionic compound. The powdered salt which you get, it is processed and converted into powder from the crystals. But the actual salt which you get, you find in the markets in the form of colorless crystals. That is the basic property of NaCl. Neutral salt, and everyone knows it is salty in taste. It has pH value 7 and it is a neutral salt. Now this NaCl, it is used for the production of different salts like Na2CO3, that is sodium carbonate, NaHCO3, sodium bicarbonate. About these salts, we are going to revise further in details, and we have studied in details about both of this in the previous session. Now, when an electric current is passed through a saturated solution of sodium chloride, you will find hydrogen gas released at the cathode while chlorine at the anode. When a salt is heated to a high temperature of about 800 degrees Celsius, it melts and it is known as the fused state of the salt. And when current is passed through this fused state of the salt or the fused salt, then you will see chlorine gas at the anode and liquid sodium metal at the cathode. What is NaCl? It is a combination of sodium and chlorine. So when this fused salt is electrolyzed, then you will find this chlorine gas at the anode and liquid sodium metal at the cathode. And finally we see what is brine. 25% aqueous solution of the salt is called saturated brine. Next salt which we have seen last time was sodium bicarbonate or baking soda. The attractive food items placed ahead of you, they get this property of softness or they become fluffy due to the presence of this small quantity of baking soda. It is a white non-crystalline powder. Its chemical name is sodium hydrogen carbonate or sodium bicarbonate. Why sodium hydrogen carbonate? You can see its chemical or molecular formula NaHCO3. So sodium hydrogen carbonate. About its properties, it reacts with moist litmus paper and red litmus is found to turn blue, which indicates its basic nature. It is used to make bread, cake, dhoklas. I have told you it is made to use this food items soft, porous and fluffy. The very important use is it is used to make the active substance carbon dioxide in the fire extinguisher. How carbon dioxide is used in fire extinguisher you have studied in chapter number 13. I had explained the entire setup of carbon dioxide, fire extinguisher, where you had seen that the sulfuric acid which is present, it comes in contact with sodium bicarbonate releasing carbon dioxide gas. The next use is used to reduce acidity in the stomach and it is used to clean an oven. Now, why it is used to reduce the acidity in the stomach? I had told you, being basic in nature, it neutralizes the excess of acid which is produced in the stomach and hence it is used to reduce the acidity problems. Our next salt is bleaching powder, that is calcium oxychloride, CaOCl2. Let us have a glance at its properties and uses. The first property is it is a yellowish white colored solid substance having chemical name calcium oxychloride. It has a strong smell of the chlorine gas. I had told you that chlorine is inconvenient to handle because of its gaseous state and hence the solid bleaching powder which has the same effect, it is used and hence it has a strong smell of chlorine gas. It is used for the disinfection of drinking water at the waterworks and the water in the swimming pool. Hence I had told you when some of the swimmers they visit the swimming pools or the resorts which have the swimming pools, you get such a type of smell. Used for bleaching of clothes, used for disinfection by the roadside and the garbage sites. Now one of the reaction, that is sulfuric acid and dilute HCl, they react with bleaching powder to release chlorine gas. This is one of the reaction with sulfuric acid. And calcium oxychloride, it reacts slowly with carbon dioxide to form calcium carbonate, that is CaCO3 and chlorine gas. Our next salt is washing soda having the molecular formula Na2CO3.H2O. Let us see its properties and uses quickly. It is whitish and having no smell, odorless powder at room temperature. Litmus has a blue color in its aqueous solution. Hygroscopic in nature. I had given you the meaning of hygroscopic. Hygroscopic means it absorbs the moisture if it is left exposed to air. I had told you, if you take a small quantity of the washing powder which you have in your house and just keep it open, then after some time you will see that it has turned wet due to its hygroscopic nature, mainly used for washing clothes. This I don't have to tell you. And sodium carbonate is used in the glass and paper industry and in the refining of petrol. Then we had just seen some of the other crystalline salts. Apart from this washing soda, bleaching soda and all, the few names quickly we will go through. First one, alum. Second, borax. Third, Epsom salt. Fourth, barium chloride. Fifth, sodium sulfate. Along with their molecular formulae, we had gone through all the molecular formulae, and I had told you that you have to revise the molecular formula of each and every salt. It can be asked in the exam. Then its uses we had seen. Alum is used in the process of water purification. Why? Because of its property of coagulation, the solid impurities in the water, they come together, they gather together, becomes heavy, and they settle to the bottom, and hence the water above it becomes clear, and that water is suitable for drinking purposes. Next, blue vitriol is used in the blood test for diagnosing anemia. Anemia is the condition where you have less amount of blood. Body X mixture, which is used as a fungicide on fruits like grapes, muskmelon, slaked lime, is used with blue vitriol. So these are some of the uses of the salts. Now the last topic to finish up with the first part of the chapter is soap. This word is not new to you. When oil or animal fat is boiled with an aqueous solution of sodium or potassium hydroxide, that is NaOH or KOH, sodium or potassium salts of carboxylic acids are formed. These salts they are called as soap. About the soap in more details you are going to study in the next year, chapter number 9, carbon compounds. More detail you are going to study about the salts. So when the soap is mixed with hard water, calcium and magnesium salts of fatty acids are formed, and this being water insoluble, they form a precipitate, and that is why lather is not formed. Now our first part of the chapter is over. Even we have done the revision of what we have studied in the previous session. Now we proceed with our today's topic, and the second topic for this chapter, radioactive substances. The name of the topic is radioactive substances. First, we will understand what we mean by radioactive substances. There are some of the elements in nature which have a high atomic number. You have studied about the elements that they have atomic mass, they have atomic number. There are some elements which have high atomic numbers. Examples are uranium, thorium, radium, which have the property of spontaneously emitting invisible, highly penetrating and high energy radiation. This property of the elements is called as radioactivity, and this elements, the substance which has this property, is called a radioactive substance. So here you can say that uranium, thorium, radium, they are radioactive substances. The nucleus of this radioactive elements is unstable. You know that they have a nucleus, and this radioactive elements, they have an unstable nucleus. So radiation that occurs from an unstable nucleus, and hence radioactive substances, they are relevant to our day-to-day life. So the three types of radiation which are given out by radioactive substances are alpha, beta and gamma rays. In details, you are going to study about their properties ahead. Our next topic is nature of radioactive radiation. Just now I have told you that this radioactive substances, they spontaneously emit high energy radiation. So about its nature we are going to study in our next topic with the help of a small experimental setup. Now, before we move towards this experiment, I would just like to introduce you with some of the facts. In the year 1889, Rutherford, he discovered that the radiations which are emitted by one of the radioactive substances, that is radium, were of two types, and they are called as alpha and beta radiation. Willard discovered the third type, namely gamma radiation. Just now I have told you the three types of radiations which are emitted, which are produced, which are given out by the radioactive substances. They are of three types. So Rutherford discovered about the first two, that is alpha and beta, and Willard discovered the third type, that is gamma radiation. So when these rays are allowed to pass through two oppositely charged plates, they get separated. You can see here two differently charged plates. One is the positively charged and one is the negatively charged. So they are seen to get separated. This method, it was introduced by Rutherford in the year 1902. So Rutherford and Willard, they studied the radiation which are emitted by the radioactive substances, and particularly for this purpose, they allowed the rays to pass through an electrical field and a photographic plate, it was held in their path. You can see here. What was found towards the end of this experiment? It was found that the radiation was divided into three types. The rays which were emitted, they were allowed to pass through an electrical field, and a photographic plate, it was placed in its path, and then it was inferred that the radiation was divided into three types. One type of radiation deviated slightly towards the negatively charged plate, while the second type of radiation deviated towards the positively charged plate. However, it was found that the third type of radiation did not deviate at all in the electrical field. You can see over here the third type of radiation not deviating towards any of the charged plates. The rays were deviated slightly towards the negatively charged plate. They were called as alpha rays. The rays which deviated towards the positively charged plate, they were called as beta rays, and the rays which did not deviate at all, they were called as gamma rays. Towards the end of the topic, you have come to know that the radiations which are emitted by the radioactive substances are divided into three types. One is the alpha rays, one is the beta rays, and the other is the gamma rays, and it was successfully found towards the end of the experiment, which was done by Rutherford and Willard. Now, if you see in your textbook on page number 156, the entire chart displaying the characteristics of alpha, beta and gamma rays is given. Just for you to understand, I will read out the chart for you. You have to learn certain things from that chart. How the questions can be asked on this part, I will tell you towards the end of the reading of this chart. Now, this is a type of distinguish between the three types of rays in the, you can say, format of the different properties which were taken into account. The first property taken into account was the nature, second mass, third charge, fourth velocity, fifth deviation in the electric field, sixth penetrating power, 7th ionization power, and 8th power to produce fluorescence. This entire chart you have in the textbook. So you can read the chart thoroughly from page number 156. First we will see the nature for all the three, then the mass. So we will study in comparison with each other. So the nature of alpha rays is current of alpha, helium particles, current of beta, electron particles, and gamma rays are electromagnetic radiation. Mass of alpha rays is 4.0028 Dalton, beta rays is 0.000548 Dalton, and gamma rays have no mass. Charge of alpha rays +2, beta rays -1, gamma rays are electrically neutral in nature, having no charge, and hence they were not deviated towards any of the charged electrical plates. Velocity 1/5 to 1/20 times the velocity of light, 1/5 to 9/10 times the velocity of light, but the gamma rays velocity is same as the velocity of light because light is also an electromagnetic radiation. About deviation, I don't have to tell you. Alpha rays are attracted towards the negatively charged plate, attracted towards the positively charged plate, and no deviation at all. Penetrating power. Alpha rays can penetrate an aluminium sheet of thickness which is less than 0.02 mm. Beta rays can penetrate an aluminium sheet of thickness 2 mm, which is 100 times the penetration of alpha particles, and gamma rays can penetrate 15 centimeter thick lead screen, which is 10,000 times the penetration of alpha particles. Means you can see that the gamma rays are the highly penetrating rays. Ionization power of alpha rays is very high, beta rays is low, and gamma rays is very low, whereas power to produce fluorescence is very high in the case of alpha rays, very low in the case of beta rays, and low in the case of gamma rays. Now, how to remember this chart and how it can be asked in the form of different questions. The first question here expectable is a direct question. Distinguish between alpha rays and beta rays, or distinguish between beta rays and gamma rays, or distinguish between alpha rays and gamma rays. This is the first type of question. So if it is a distinguish between, then you have to look at the amount of marks allotted to the question. For 2 marks, you have to give 4 points. For 3 marks, you have to give 6 points. Now, any properties you can write here for distinguish between. Some can write about the mass, charge, ionization power. Some will write about the nature, velocity, depends totally on you. Second, I can ask, give any 2 or 3 characteristics of alpha rays or beta rays or gamma rays. This can be a direct type of question. And the third is under MCQs. Mass of alpha rays is dash Dalton. Then different masses will be given. You have to select the correct one. So what indirectly I want to highlight over here is each and every point should be remembered by you thoroughly. Do not skip. The teacher has told it can be asked for distinguish between, or teacher has told any 3 characteristics will be asked. So why to study all 8? Don't do that. Because suppose I ask an MCQ on mass, then unless and until you know this value, you will not be able to select the correct option, select the correct answer. So each and every point, try to study. You have lots of time with you. So one day also if you sit with the chart, highlight the chart, take out a printout in higher font and put it on your in your bedroom or the room which you stay in. Every day morning when you get up, go through it. Towards the end of 15 days, you will be thorough with the entire chart. Now, the next topic is the uses of radioactive isotopes. When you just try to find out the uses of radioactive isotopes, it is a misconception that radioactive elements means they are used only for making an atom bomb, means it has only destructive uses. But practically it is not so. Radioactive isotopes, they are used widely in various fields. They have different advantages in various fields such as scientific research, agriculture, industry, medicine, etc. BARC, Bhabha Atomic Research Center is the center which works completely on this radioactive isotopes and taking into account all the radioactive elements. So such a type of big plant, when it is situated, then surely the radioactive elements or the isotopes is not such that they will have only destructive uses. Now this radioactive substances, they are used in two ways. One is by using the radiation alone, and second is by using the radioactive element itself. Now if you see in your textbook, page number 157, the uses of radioactive isotopes in different fields are given, but that entire block is removed out from the syllabus due to the pandemic. How these radioactive isotopes, they are used in industrial field, how they are used in the field of agriculture, how they are used in medical science. Actually their uses, the main part they have removed out from the syllabus. So this will mean that no questions will be asked on this part in the exam, surely. But for your information, for your extra knowledge, when you have some time which is excess with you, you can just go through the uses, because uses are extremely important. So go through the uses if you get some time. Next, the difficulties, or you can say the disadvantages of radioactive substances and the radiation. As every coin has two sides, the disadvantages will also be there. The first is it affects the central nervous system, that is the CNS. The CNS is affected by radioactive radiations. About the CNS, you have studied in chapter number 15 in section B. It comprises of the brain and the spinal cord. So this radioactive radiations can harm the central nervous system. Hereditary defects are generated by the bombardment of radiation on DNA in the body, and this affects practically, you have the knowledge about the bomb attacks in Hiroshima and Nagasaki. The generations which are born till now, the hereditary defects are passed on. They can be clearly seen. Cause diseases like skin cancer, leukemia, etc. This radioactive radiation, they have the ability to penetrate the skin, and thus this different types of diseases are caused by it if you are exposed to it for a longer amount of time. Radioactive pollutants, they created due to the explosions, they enter the body through the air and it is difficult to control them. Radioactive pollutants released in the seawater, they enter the bodies of the fishes, and when these fishes are consumed by human beings, they enter the human body and cause harm to us. The radioactive paint on the watch, sometimes watch, they shine during the night time due to the radium and all which is present. It can cause cancer. Radioactive isotopes strontium-90 can enter the body through the plants, fruits, flowers, cereals, milk, etc. and they can cause various diseases like bone cancer or leukemia. So now why they have kept the disadvantages and why the uses are skipped off, that depends totally on the education department. But once you come to know about the disadvantages, then you will also know how to have a control on its use. So which radioactive substances to be used more and which can be just ignored, that you have to select. About the uses, as I have told you, go through it, because uses or positive sides should be memorized more. And with this we complete with the discussion of the second topic of the chapter, that is radioactive substances and radioactivity. In our next session, we are going to start with the last topic of this chapter. We are going to study about the different chemical substances which you use in your day-to-day life in the form of food colors and essences, dyes, artificial colors, deodorants, etc. And hence I will request all of you, dear children, every time I go on telling you, even in the class, when we attended the offline sessions, there I had seen, I had made you to read the chapter. As the name of the subject is science and technology, reading is the, you can say, basic need of today's hour for the subject, and hence you have to emphasize more, give more times towards the reading of the chapter. Try to complete your reading of the chapter before the exam at least 3 to 4 times. And reading doesn't mean just going through it very hastily. Read each and every concept very slowly. Try to attempt all the questions on that page, whatever, maybe use your brain power or different activities. Try to draw the diagrams which are there on the page. Try to go through the numerical examples. This is called as reading. So before you attend our next session, the last topic which is there in your chapter, I request all of you to read and then attend the session. Thank you, dear children.